Okay, so I want to just introduce some general concepts from Chapter 7, which is all on hypothesis testing, okay? And so with confidence intervals, we were able to come to a conclusion about whether the means of two populations are different or not. Okay, are they different, or maybe they're not. Okay, and with hypothesis testing, at least with the first hypothesis test, we are going to do the same type of thing. Okay, but the approach is a little bit different. Okay, we start off with a pair of hypotheses. Okay. We have what we call the null hypothesis, which is written H sub 0, okay? And this is kind of the statement, and this is the statement where nothing interesting is happening, okay? Okay, and in this case, what happens is that we assume that the null hypothesis is true. We assume that the null hypothesis is true, and if there's anything unusual in our data, okay, we attribute it to random chance. Okay. And in most of research, you are hoping to eventually reject the null hypothesis, okay? So note, in general, researchers hope to reject the null hypothesis. Okay. All right. So that's the null hypothesis. The other is the alternative hypothesis. Which we write as HA, okay? And this is basically, this says the null hypothesis is not true. Okay, this says states that the null hypothesis must not be true. States null hypothesis is not true, and unusual things observed in our data are partially due to chance, but also due to the fact that something interesting is happening, okay? That there is something, quote, Interesting. Okay. Okay. And so the way we conduct research is we create a pair of hypotheses, and the null hypothesis is kind of the status quo, nothing interesting is happening. And we say, well, here's this data I observed. If we assume that nothing interesting is happening, how likely, what is the probability that I will observe this data that I have? Okay. We create our hypotheses. Okay. We then ask, okay, then we then gather data, I should say. And we ask, okay, if I assume the null hypothesis is true, you know, how likely or unlikely basically, what is the probability? How likely or unlikely am I to observe the data that I have? All right. Is this okay? So I'm going to continue on. So let's just try a silly example here. Okay. Let's say you're playing a game with a friend, okay? Okay. And the game is very simple. You just flip a coin, and if it lands heads, your friend wins, and if it lands tails, you win, okay? Okay. And let's say you have to leave, but you promised you'll play 10 rounds, okay? So you'll play 10 rounds, and you're not there to view the coin flips, okay? So you don't view the coin flips, okay? And overall, you trust your friend, okay? So he comes back and he says, hey, I flipped it 10 times. I won seven times, and you won 3, okay? You don't view the coin flips, okay? And so he says, okay, so he tells you, I got 7 heads, 3 tails. And you say, oh man, you won more, okay? But if this happens, would you question the integrity of your friend? you would immediately say, I think you're cheating? Or does it seem like, oh, maybe he just got lucky. He got 7 heads and you got 3 tails? I mean, he could be lying, but what's your feeling here? He got 7 heads and 3 tails. You didn't view the coin flips, but you know. Could this have happened just from dumb luck? Yeah. Okay. This of course it could have happened just by dumb luck, and so we can say, you know, what is the probability that this happened just by luck? Okay. Well, we can actually answer this, right? On the other hand, okay, and we could do the math, but we would get the sense that the probability of this outcome is not very small, right? It's reasonable, right? It's not an incredibly small value, right? So, you know, our intuition says the probability of this outcome by random chance is not small. Okay. Is that okay? All right. Let's say you're going to play 100 rounds, okay? Play 100 rounds. Again, you don't observe the flips. You don't see the flips. Okay? And this time, he says he got 70 heads and 30 tails. Okay. Do you still believe that this happened by chance? No. Now it feels like, you know, in both cases he won 70% of the games. But this time, getting 70 heads, that feels a little bit too bizarre, right? So we say, you know, what's the probability of getting 70 heads just by pure luck? What do you think? Like, is it technically possible that he got 70 heads just by pure luck? Technically it's possible, but something tells us that it's very highly unlikely, right? So, you know, what is the probability of getting 70 heads just by luck? Okay, so technically it is possible, but it is very unlikely. Okay? And because it's so unlikely, we will come to the conclusion that maybe he's not telling the truth anymore. Okay? Because it is so unlikely to happen, by chance alone, okay, we conclude that it was not a result of pure chance. That, you know, our results is not from chance alone. Is that okay? All right. And so in both of these cases, all right, the pair of hypotheses, the pair of hypotheses that we used in both cases here is that the null hypothesis is, basically the friend is playing fair, meaning that the probability of getting heads is 0.5. The alternative hypothesis is that, the friend might be cheating, and that the probability of heads has been altered to be greater than 0.5. Okay? So we are just asking, okay, if I give you the benefit of the doubt, how likely are you to get 7 heads out of 10? Well, it happens with a decent amount of probability. Okay? Does that prove that he's playing fair? No, he could be cheating. Okay? It does, the fact that 7 heads is a likely outcome from chance alone doesn't prove that he's playing fair, but it's not enough for us to say he's cheating. Okay? On the other hand, getting 70 heads out of 100 flips, that seems quite incredible. Okay? And because it's quite incredible, we conclude maybe he is cheating after all. Okay? Again, it's possible that he was actually playing fair and he got just incredibly lucky and happened to get 70 heads out of 100 flips. Okay? So that is also a possibility. And I guess you have to ask yourself, well, is this worth, am I willing to accuse my friend of cheating or whatever? There's kind of this, what's the risk-benefit of making possibly the wrong conclusion based on the data that we have here, okay? And so when we're asking this question, what is the probability that this happened just by luck, or what is the probability of getting 70 heads just by luck? The answer that we answer to this question, what is the probability of getting our data just by luck, or just while we assume the null hypothesis is true, that is the definition of our p-value. Okay? So when we ask, so I will say our p-value, this is equal to the probability of observing our data. Okay, and I have to throw in this phrase, or something more extreme if we assume the null hypothesis is true. Okay, so it is the answer to the question what is the probability of getting, something like 7 heads just from pure luck. Okay? Because in our case, the null hypothesis is probability of heads is equal to 0.5. Anything different from that is from luck alone, or random chance. Okay, so it's the probability of getting our data, 7 heads, if we assume the null hypothesis is true. Okay, And so, you know, for example 1, we have 10 flips and we got 7 heads, okay? So our p-value is equal to the probability of getting 7 heads or something more extreme. So that means getting 7 heads or 8 heads, 9 heads, or 10 heads. So 7 heads or more, because, you know, if we suspect our friend is cheating when he won 7 heads out of 10, we would also suspect he was cheating if he got 8 heads, 9 heads, or 10 heads, right? So the p-value would be the probability of getting 7 heads or more if we assume he is playing fair. Okay, do we know how to answer this? This would be 10 choose 7, 0.5 to the 7 times 0.5 to the 3, right? Plus 10 choose 8, plus 10 choose 9, plus 10 choose 10, right? All of those, okay? Or it would be what? I could do this on some d binom 7 through 10 of 10 comma 0.5. This is, I could get, this is my p-value, right? Or 10 choose 7, 0.5 to the 7, 1 minus 0.5 to the 10 minus 7 or 3, plus 10 choose 8, dot 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 dot, 10 choose 9. Yeah? Okay, so let's just see what that comes out to be. Sum d binom 7 through 10 of 10.5. Okay, 17, 0.1718, 0.1719. Okay, so that means your friend would get 7 heads or more from pure luck about 17% of the time. Okay? So this is a I would say this is a non-negligible probability. We're not ready to accuse him of cheating, because this happens more often than someone just, you know, if you say roll the die, you win if you get a 6, someone rolls the die and they get a 6. You wouldn't say, oh, you're instantly, I think you're cheating, right? Just happen to get lucky. So definitely, you know, this doesn't prove that he's playing fair, but it's certainly not enough to say he's cheating. Okay? Is that okay? And in the other situation, right, we had, so example 2, we had 100 flips, and he won 70 times, okay? Well, I have the computer, so how would I do, how would I calculate my p-value? This would be the probability of getting 70 heads or more, you know, from random chance alone. So this would be sum of d binom everything from 70 up to 100 based on 100 flips and a probability of 0.5. Okay? Or I could do 1 minus p binom 69. Is that okay? So what do you think this number is going to be? It's going to be really small, right? We can try it. So sum of d binom 70 through 100 based on 100 flips, probability 0.5. I have 3.925 times 10 to the minus 5. So if I move this over 1, 2, 3, 4, 5, this would be 0.012334. Okay, so it's about basically about a 4 in 10,000 chance of happening. Wait, hundreds, thousands. Oh no, 4 in 100,000 chance. I'm sorry. 1 in 10 to the minus 5. Yeah, 4 in 100,000. Okay. 4 in 100,000. So it could happen, but it's so incredibly unlikely of happening just by random chance. It's a lot easier for us to say, you know what, yeah, technically it's possible, but this probability is so small, I don't think it happened this way. I think the much more easier explanation is maybe he fudged the numbers a little bit or something, right? Is it possible? Yeah. Is it likely? Certainly not. Okay. All right, and so this is kind of the notion that we have when we approach hypothesis testing. Okay. We set up a pair of hypotheses, the null and the alternative, and then we ask, what is the probability of getting the data that I have if we assumed that the null hypothesis is true? Okay, and so all of our calculations are based under the assumption that the null hypothesis is true. Okay, so so you don't have to worry about this for the midterm exam, but we're going to start covering this in chapter 8, and we're going to kind of move through. So please just make sure you're familiar with these concepts of null hypothesis, alternative hypothesis, and the p-value. I'm sorry, when we get into chapter 7 during the week after the midterm. Okay. Okay, so let's just do a quick maybe inventory of the topics that you should know for next week's test. All right, so topics. So a lot of this is listed online, but I'll start off with there will be a few general conceptual questions. So stuff like maybe definitions of the mean, median, standard deviation. Maybe you should be familiar with the empirical rule for the normal distribution. Be able to describe shapes of distributions. And the law of large numbers. Okay. So, like, what's the conceptual definition of the mean?
Like an average?
Well, that can also be said about the median too, right? So conceptually, what? The mean is the balance point of our data, and the median is the halfway point. Okay. What about the standard deviation?
Like
Yeah.
spread?
Yeah, well, standard deviation and IQR both tell us spread, but standard deviation is kind of like the average or typical distance from the mean. It's technically the square root of the variance, which is the average squared distance from the mean. Standard deviation is the square root of that. IQR would be the distance from the third quartile to the first quartile. Okay. Make sure you can read a box plot. Yeah.
Definitions for those are the ones from your notes or the ones from the book?
I think the ones from my notes and the ones from the book are close in agreement.
Okay.
I mean, maybe I used a couple different words, but I hope. I don't know. Okay. All right, so reading a box plot, we know how to do this, right? You should be able to, if you see a box, identify Q1, Q3, IQR, median. Okay, make comparisons between box plots. Okay. We have some probability questions. So, probabilities of different events. And combinations of events. So, and or. Random variable questions. With a mean of a random variable and standard deviation of a random variable. Binomial probabilities. And then you'll have to deal with a probability tree. Okay, and answer, probability of A given B, and versus probability of B given A from a probability tree. So this is, what's the probability of a delay given a storm versus what's the probability of a storm given that there was a delay, and make sure you can answer both of those things. Okay. And then probabilities based on a two-way table. So a two-way table is one of these things. A, not A, B, and not B. Blah, 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 right? I understand independence and versus mutually exclusive. you have any questions on this? Okay, and then all right, and then you'll have some, whoops, what am I doing here? It's the wrong button. Okay, we'll have some normal distribution questions. Both the forward reading and the inverse reading. You'll have a normal approximation to the binomial. Binomial distribution with the continuity correction. And again, this is the only time you use the continuity correction, is the normal approximation to the binomial. Okay, and then you'll also have sampling distribution questions. Okay. You'll also have confidence interval questions. Okay, so make a CI for mu based on one sample. Make a CI for mu1 minus mu2 based on two samples. Okay, and then for both of these, you should also know the appropriate conclusion. Okay, and then be able to identify the parts. Which would be the center, the margin of error, which is made up of the critical value and the standard error. Okay. And then you have one question on R, and it's kind of similar to the types of R questions that were on today's quiz. Okay. Okay, that pretty much covers everything covered on the exam, I think. Yes, question.
Remembering when we did probabilities based on the two-way table?
I didn't cover it in lecture. You're right. I did not cover it in lecture. It was covered in the homework.
Okay.
And we can do an example of that. It would be something like I don't know. We have left-handed and right-handed, and we'll ask something like I don't know. I don't know. Wears glasses and no glasses. Okay, and then maybe we have 10 and 12, 22, and 60, and 80, I don't know, I'll say 72, and so what's that, 132 for a total of 154, 70 and 84. Okay, so then I could ask something like, what is the probability that someone wears glasses? Okay, and you would say, and then what would be the probability of left-handed? And what is the probability of left-handed given glasses? Oh, this is the numbers they selected are not maybe not be the best example. Okay, or I could say probability of no glasses given right-handed. Okay, or I could say, you know, what percentage of people who are right-handed also wear glasses versus what percent of people are right-handed and wear glasses. Okay, so glasses would be 70 out of 154. Left-handed would be 22 out of 154. Left-handed given glasses would be 10 out of 70. And no glasses given right-handed would be 72 out of 132. Okay, and then that's this question. What percentage of people who are right-handed also wear glasses? That would be 72 out of 132 turned into a percentage. Okay, what percentage of people are right-handed and wear glasses? This would be 72 out of 154. Okay, so
How'd you get 72 out of 132 for that?
did I mess up?
I don't know, I don't know.
Oh, also wear glasses. I'm sorry, also wear glasses. It would be 60 out of 132. I'm sorry. 60 out of 132 and 60 out of 154. I'm sorry. My bad. Okay. And is this okay? So this one, the key here is this says of people who are right-handed. And this one just says of people.
But it says of people are right-handed.
Who are right-handed. So here we are limiting ourselves only to right-handed people. There's only 132 people who are right-handed. So what percentage of people who are right-handed? We are limiting ourselves to just these 132 right-handed people. How many of them also wear glasses? 60 of them. Over here it says what percentage of people are right-handed and wear glasses. So here we got 154 people total. 60 of them are right-handed and wear glasses. Okay, so that would be answering questions from a two-way table. Okay, well, good luck as you guys study. We'll see you guys next week.